All right, good morning. Let's get some radical math going here, yeah? All right, first one here. Rationalize the denominator for me. So we only have 1, 2, and a fourth root. So if we had 3 more, we could pull a single 2 out. So we're going to multiply the top and bottom. So I wish I had it so I could work it down, but I'll just rewrite 432 over this. That's the original. Now you want to multiply by fourth root because you want these radicals to be the same so you can combine them. I'm going to put 3 of them in here. And I have to do the same to the top. So now you have, if I multiply this, now you're going to have, I'll just write it out. 2 times 2 times 2 times 2. Now we're going to have fourth radical, 32. What's 32 is 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2. That's 32 is the 1, 2, 3, 4, 5. And then 3 more from multiplying the top. This is what radical math is. Embrace it. Just a lot of busy work. Okay, this is what we have. So on the bottom, we're going to get 2. On the top, this is a fourth root. We got 1, 2, 3, 4. 1, 2, 3, 4. Okay, good. Next one. This one's kind of, I don't like this one so much. I know Kara doesn't like any of them, but I don't like this one so much. Here we go. So 27. Make sure you just factor everything, you know? Especially when you have something like this, because you know that is 3 times 3 times 3. This is another one. You just want to rationalize the denominator. Keep that as 5. So if I want to get rid of this denominator, if I want to rationalize and get rid of the radical, fifth root, 3 times 3. I have to do the same thing to the top. So now I have 1, 2, 3, 4, 5. So that means I'm just going to have a single 3 in the bottom. I'm going to have 15, fifth root, 45. Check that out later. Could be wrong, but that's what I'm going with. Okay, this. So now, this is 13 one's easy. So what are the radical rules we have to remember? I always write the same thing. So you got to know what that can be simplified to. You have to know what that can be simplified to. You have to know what that can be simplified to. Pretty much all the rules. There's one more. If you have x to the 5th over x third. If you remember these 4 things, you can derive everything else. What's this? Add the exponents. X to the 5th. If it's raised to an exponent, multiply. X to the 6th. These are like terms. You don't change the exponents at all. And you can only add them if they're exactly the same. X to the 5th divided by x to the 3rd. You subtract 3 out of 5. So you subtract the denominator from the numerator. You want a couple more easy log rules. There's this one, right? X to the negative 2 is 1 over x squared. So this is just the simple. These are the simple rules. These are the more complicated applications. But you look at this one. What is this one? This is that. So it's not hard. So you're just gonna, if you have them multiplied, you got like bases. This is important. If this was x to the 5/3 times y to the 4/3, you could not combine them. Like bases is an important vocab word you need to know. Same bases, add the exponents. Have a nice day. Okay, this is pretty simple too. But just like before, always factor stuff. What's 16? 2 times 2 times 2. That's 2, 4, 8, 16. X to the 4th. Now since we have a cube root, we're looking for sets of 3. If we have a set of 3, we can pull a single 1 out. Here's 3. I'm going to pull a single 2 out. There's 4 here. This really is x times x times x times x, which means there's 3 of them. There's at least 3. So I'm going to take 1, and I'm left with 2x. Right, based on this exponent, I pulled out 3 of them and left 1 in there. So there you have it. Let's keep going. All right, 24. Gross, as Kara would say. Okay, good one. Look, see, they can always get a little trickier. So what they're trying to check to see if you'll do, they're trying to give you a carrot to make it, see if you'll take the bait and mess it up. You cannot combine these because the radicals are different. This is a square root and this is a cube root. So in this case, we want to rewrite as fractional exponents. So we can distribute this to here. So we get, let's first rewrite this as fractional. X to the 4/3, yeah? 3 is that goes in the denominator, the root goes in the denominator, times x to the 5/2. So I rewrote these as fractional exponents. Now it's going to be easy for me to do this, which remember is the same application of this. If it's raised to a power, you multiply it through. So this becomes x to the -8. So always remember, obviously, with this, your fraction rules. If you multiply a number times a fraction, you just multiply the numerator and the denominator. This is 2/1. -8/3 times x to the -10/2. Okay, now we have this rule, which is this rule. We want to add them. We have like bases, so we can add these. We just need a common denominator. What's the common denominator? 6.